elementary particles. In physics, particles that cannot be broken down into any other particles are called elementary particles. The term elementary particles also is used more loosely to include some subatomic particles that are composed of other particles. Particles that cannot be broken further are sometimes called fundamental particles to avoid confusion. These fundamental particles provide the basic unit that make up all matter and energy in the universe. Scientists and philosophers have sought to identify and study elementary particles since ancient times. Aristotle and other ancient Greek philosophers believed that all things were composed of four elementary materials: water, fire, air, and earth. People in other ancient cultures developed similar notion of basic substances. As early scientists began collecting and analyzing information about the world, they showed that these materials were not fundamental but were made of other substances. In the 1900s, British physicist John Dalton was so sure he had identified the most basic object that he called an atom, Greek for indivisible. By the early 1900s, scientists were able to break apart this atom into particles that they call the electron and the nucleus. Electrons surround the dense nucleus of an atom. In the 1930s, research showed that the nucleus consists of smaller particles called the proton and neutron. Today, scientists have evidence that the proton and neutron are themselves made up of even smaller particles called quarks. Scientists now believe that quarks and three other types of particles, leptons, force-carrying bosons, and the Higgs bosons are truly fundamental and cannot be split into anything smaller. In the 1960s, American physicists Stephen Weinberg and Sheldon Glashow and Pakistani physicist Abdus Salam developed a mathematical description of the nature and behavior of elementary particles. Their theory, known as the Standard Model of Particle Physics, has greatly advanced understanding of the fundamental particles and force in the universe. Yet, some questions about particles remain unanswered by the Standard Model, and physicists continue to work toward a theory that would explain even more about particles. So that's why I tell you about this text, and I'm Alina Oktavianti. Thank you for your attentive and attention. See you next time.